Alright, tonight, gentlemen, we're going to take notes regarding Newton's third law. This is a second set of notes focusing on force pairs. Now, when we draw force body diagrams, or free body diagrams rather, if I draw a box with a man pushing it, there he goes, he's pushing the box. Alright, if we drew a free body diagram for the box, we have our box. You know there's a force of gravity. And then this, please note, we're changing the term. The more formalized term is the normal force. So the normal force, we're changing normal from support. So free body diagram. And a key change is support equals normal. Now, the other forces here are the applied force by the man. So here we go. This is a force applied, and we have a frictional force applied by the ground, force of friction. Okay, I'm adding another component. Please don't let this confuse you. Alright, the normal force is exerted on the crate by Earth. And the gravitational force is exerted on the crate by Earth. Now, the applied force is exerted by the human, or is exerted on the crate, by the human. And the frictional force is the Earth, put on the crate by Earth. Notice everything is applied by something else. This is going to come in handy when it comes into force pairs. Alright, something else I want you to realize. Alright, notice every force that we have here. I'm going to type because it looks a little neater. Every force that we're dealing with here has interaction between two objects. You can't have a force without two objects applying onto each other. And you guys know Newton's third law states the following. So you've already learned that equal and opposite forces equal and opposite forces, right? So when objects interact, so this is key because they have to be interacting, they exert equal, where'd my typing go, and opposite forces. Alright, so let's explain in better detail. So force pairs, what are they exactly? They are, it's going to work from here, equal and opposite forces of the same type of force, and I'll explain that in greater detail, that objects exert upon each other. Okay, that seems repetitive, but I think for some of you it's a little confusing to picture like two different size objects applying forces on each other. So let's take a look at this. What they must be. Okay, things that they must have, or components they must have. Alright, they must be, one, equal. And when I mean equal, I mean in magnitude. Remember, that's the arrow. Okay, they should be opposite. In this case, I mean their direction. So these are vector quantities. We're talking about direction and magnitude. And it has to be the same kind of force. This means if it's a if it's a force of weight, it must be an equal and opposite force of weight. if it's acceleration, if it's normal force, aka support force, if it is a tension force or a frictional force, or A would also be an applied force. So these forces have to be the same. So if it's an applied force on a box in the eastward direction, then the applied force that the box applies on your hand in the westward direction would be the exact force pair. Alright? Force pairs cannot be, okay, the things that they cannot be. 1, they cannot not be different magnitude. Those magnitude arrows have to be the same, otherwise it is not applied to the law. They cannot be, or they cannot not be in opposite directions. So if they are not directly oppositional, so let's draw a couple pictures here. So in this case, if there are different magnitudes, this versus this is wrong. They can't be like this versus this. That's not the same direction. Alright, last but not least, they cannot be different types of forces. Okay, let's demonstrate what I mean by this exactly. So I'm going to draw a picture of you on Earth. So here's Earth, and here's you. You're large compared to Earth, apparently. Okay, if I separated out the Earth, here's Earth, and here's you, standing on Earth, and drew force diagrams, here's what I would see. We have the force of gravitational pull, alright? And then the normal force. You're stable, so those magnitudes are the same. But this is a different magnitude. The normal force, sorry, I should have drawn it different colors. The normal force is different than your force of gravity. So this is force of normal, and the other is force of gravity. Force of gravity. And in this case, the you, or the person, is exerting force on the Earth, or by the Earth. Alright, the Earth is applying this force, and your normal force is your person, the person being exerted on by Earth. That's that upward force. Now if I drew the same force diagram, we would have the force of your gravitational pull. So yes, remember, you do have gravitational pull, but your acceleration is negligible because of your weight. Your weight is so insignificant compared to the Earth. But you do have a force applied on the Earth by you. And there's also a normal force, which is equal and opposite. Force normal. Alright, applied by you onto the Earth. So Earth by you. Here are the equals. So the normal forces are equal and opposite each other. The gravitational forces are equal and opposite. These in red, or those in blue, are your force pairs. They cannot be, your force pair would not be the same two forces applied on one object. They're the equal and opposite forces as you see here.